In this section, we're going to cover an introduction to probability. So some definitions we need to know. An experiment is considered an activity with observable results, a planned operation that's carried out under controlled conditions. So it doesn't have to be a very big production of an experiment. For us, an experiment could simply be we're going to flip a coin a certain number of times and observe what happens, or we're going to draw a card from a deck and see what happens. So it's just an activity where we can observe the results. A trial is one repetition or instance of an experiment. You then take the trial and it is repeated multiple times. An outcome is any possible result. The sample space is the set of all possible outcomes of an experiment. So you've got outcomes, and then all of the possible outcomes make your sample space. And then an event is a subset of the sample space of an experiment. Okay, so those can get a little bit confusing. Let's kind of practice those. This says you're playing a game with a friend using the following colored spinner. The spinner is spun 10 times and the color that the needle lands on is recorded. Okay, so what is the experiment? The experiment is simply spinning the needle 10 times. Right? That's what we're doing. We're spinning it. We can observe those results. That's as simple as it needs to be an experiment. What is a single trial? Well, that would be one spin. And then they're going to repeat that 10 times. What is an outcome? So an outcome is any possible result. So an outcome for us would be the color that the needle lands on. The sample space is the set of all possible outcomes of the experiment. So the sample space is a set. The sample space is usually called capital S, and it's written in braces, which indicate that it's a set. And then you write down every possible outcome. So in this case, all the possible outcomes would be red, white, purple, green, blue, and orange. And that would be all of them. And then it says, give the event the spinner points to a primary color. So this is going to be a subset, a smaller set of S. So I'm going to call this maybe this set P for primary. Let's see, primary colors, we do have red and blue, and yellow is the other primary color, but that's not an option, so just red and blue. So notice that each one of the elements in the subset or the event is also in the sample space. That's what it means to be a subset. It just means it's a smaller set that is contained inside the sample space. Okay, what is probability? The probability of an event E occurring is the measure of the proportion of the time that the event E will occur in the long run. The notation is P parenthesis E, or read P of E, is the notation for the probability of the event E. Okay, there is what we call the theoretical probability. This is the long-run relative frequency, the relative frequency at which an event happens after infinitely many repetitions. So if we could do something an infinite amount of times, that is our theoretical probability of that event. So as an example, the theoretical probability of tossing a head on a coin is 50%, and that probably seems right and feels right to you. The reasoning is because if you could toss a coin an infinite number of times, then exactly half, or 50%, of those flips would be heads. Okay, so this is in theory. We can't actually flip a coin infinitely many times. But if we could, it would come up exactly 50-50, which is why we accept that as the theoretical probability. If E is an event in a sample space S, and S has equally likely outcomes, then we can calculate the probability of this event E by doing, so what we can do is we can take the number of favorable outcomes over the number of total outcomes in S. So basically you make a fraction. That's how you calculate a probability. How many total ways could this happen? And then on top, how many are specifically favorable to what we're talking about this event. Probabilities are also always numbers between and including 0 and 1, or because they can be expressed as fractions, decimals, or percentages, 0% and 100%. So you can give them as decimals, you can give them as fractions, or you can give them as percentages. Always be careful to double check your directions on your problems as to how they want your answers given back. Let's go back to the spinner experiment. It says, what is the probability that you spin the spinner and the needle points to a primary color? So in this case, I'd be finding the probability of, and this looks a little bit weird because I named that P, so the probability of a primary color. Notice in the denominator, we're supposed to put the number of total outcomes in S. So if you remember from above, there were 1, 2, 3, 4, 5, 6 total outcomes in the sample space. And how many are favorable as far as being a primary color? So how many of those ended up in that event? There were 2 ways that that could happen. So there are 2 out of 6 ways to spin a primary color, which reduces to 1/3. I would probably just leave it as that reduced fraction. You could divide that out and get approximately 0.33 repeating, or 33.33% forever. But 1/3 is probably a good way to leave that.